I'm Mary Swarnalatha, working as assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the problems on the power spectral density of a random process. The first problem is, let the autocorrelation function of a certain random process x of t be given by Rxs of tau is equals to a square by 2 into cos omega tau. Find its power spectral density Sx of omega. So what they are given? They are given that x of t is a random process. And then they have given what? The autocorrelation function of the random process, which is given by what? A square by 2 into cos omega tau. If you observe this, the autocorrelation function depends on only the time difference tau. Therefore, you can say that the given random process x of t is a Wide-sense stationary random process. After that, what you have to calculate? You have to calculate the power spectral density of the random process x of t. It means you have to calculate the power spectral density of the random process x of t. Then nothing but what? Sx of omega equals to what? So in the previous lecture, already we have seen the relation between the autocorrelation function and the power spectral density. So if x of t is a Wide-sense stationary random process, then the power spectral density of the random process, which is given by what? The Fourier transform of. So what is Sx of omega is equals to what? The Fourier transform of the autocorrelation function. Therefore, Fourier transform of, what is autocorrelation function? Nothing but Fourier transform of Rx of tau. What is Rx of tau equals to a square by 2 into cos of omega naught tau. So a square by 2 is constant. Therefore, bring it outside. So a square by 2 into Fourier transform of, you can write e power cos of theta is what? E power j theta plus e power minus j theta by 2. Similarly, cos of omega naught tau, you can write down as what? E power j into omega naught tau plus e power minus j into omega naught tau by 2. Here, 2 is constant, 1 by 2, bring it outside. Then you can write this as what? A square by 4 into Fourier transform of e power j omega naught tau plus Fourier transform of e power minus j omega naught into tau. Therefore, what is the Fourier transform of e power j omega naught tau? Nothing but what? 2 pi into what is a, we know that what is a Fourier transform of a constant a is equals to 2 pi a into del of omega. Similarly, what is the Fourier transform of 1 equals to 2 pi into del of omega. But what you are doing here? Nothing but what? The Fourier transform of 1. Nothing but del of omega. You are shifting in the frequency domain. Then what can happen here? So nothing but then what can happen here? 2 pi into del of omega. So if you shift in the time domain, then what will happen? You have to multiply in the frequency domain. Therefore, the Fourier transform of e power minus j omega naught t into 1. Nothing but what? 2 pi into del of omega minus omega naught tau. So therefore, what is the Fourier transform of e power j omega naught tau? So e power j, in place of t, here have what? Tau. Therefore, in place of t, have here tau. So e power plus j omega naught tau, nothing but 2 pi del of omega minus omega naught tau. Similarly, what is the Fourier transform of e power minus j omega naught tau into 1? Nothing but 2 pi into del of omega minus of minus omega, nothing but 2 pi del of omega plus omega naught. Therefore, what is the Fourier transform? Nothing but a square into pi by 2 into pi into del of omega minus omega naught plus del of omega plus omega naught. Rs they can write down directly. We know the Fourier transform of cos omega naught tau is nothing but what? 2 pi into del of omega minus omega naught plus del of omega plus omega. Directly also can write down, or else can split and then you can write down the Fourier transform. Next question is, describe the power spectral density function Sx of omega of a Wide-sense stationary random process of t has the autocorrelation function Rx of tau equals to a into e power minus b into mod tau, where b is a constant which is greater than 0, and calculate the average power expectation of x square of t. It means they have given x of t is a Wide-sense stationary random process, and they have given its autocorrelation function is equals to what? A into e power minus b into mod tau. So what you have to calculate? You have to calculate what is power spectral density Sx of omega, and also you have to calculate the average power of the random process. So in the previous problem we have seen what is the relation between power spectral density and the autocorrelation function. Sx of omega is equals to what? Fourier transform of the autocorrelation function Rx of tau. So Fourier transform of what is the autocorrelation function here? A into e power minus b into mod tau. So what is the Fourier transform of a function x of t formula? So integration minus infinity x of t into e power minus j omega t dt. Similarly, Fourier transform of Rx of tau is equals to what? Integration minus infinity Rx of tau into e power minus j omega tau dt. Therefore, what is Rx of tau is nothing but a into e power minus b into mod tau into e power minus j omega tau dt. Therefore, what is mod tau value? Mod tau is equals to what? It is minus tau when tau is less than 0. It is tau when tau is less than equals to 0. Therefore, when it is less than 0, nothing but what? From way to way, from minus infinity to 0. Greater than equals to nothing but from 0 to infinity. So, for negative values of tau, what is mod tau value? Minus tau. So, minus tau into minus b, nothing but what? B tau. So, e power b tau into e power minus j omega tau d tau plus for positive values of tau, mod tau is nothing but plus tau. So, e power minus b tau into e power minus j omega tau d tau. So, if you simplify this, then you will get the power spectral density of the random process nothing but 2ab by b square plus omega square. And second problem, what you have to calculate? You have to calculate the average power of the random process. So, from the properties of the autocorrelation function, so what is the autocorrelation function tau equals 0 nothing but what? E of x square of t. Because what is autocorrelation function formula? Expectation of x of t into x of t plus tau. If tau equals 0, then what can obtain here? Rx of 0 is equals to expectation of x square of t for a Wilson stationary random process. Therefore, substitute tau equals 0, then you get the average power of the random process. So, nothing but Rx of tau at tau equals to 0. What is Rx of tau here? A into e power minus b into mod tau. So, a into e power minus b into mod tau where tau equals 0. It equals to what? A into e power 0 equals to what? A watts. Since there is a power, here it is nothing but here watts. So, next question. Find the average power in a random process defined by x of t equals to a cos omega naught t plus theta, where a and omega are the constants and theta is a random variable uniformly distributed in the interval 0, pi by 2. So, what they are given here? They are given the random process. X of t is a random process, and they have defined the random process x of t is equals to what? A cos of omega naught t plus theta, where what is here a and omega naught are the constant and theta is a uniform random variable which is uniformly distributed over the interval 0, pi by 2. So, for uniform random variable, what is the density function? F theta of theta equals to 1 by, if x is a uniform random variable distributed over the interval a, b, and what is the density function is equals to 1 by b minus a when x is from a to b and 0 otherwise. In place of x now theta is a random variable. In place of a you have 0. In place of b you have what? Pi by 2. Then what is the density function of the uniform random variable theta? Nothing but f theta of theta equals to 2 pi when theta is from 0 to pi by 2 and 0 otherwise. Now what is the average power? So what you have to calculate? You have to calculate the average power. Then what is average power? Nothing but expectation of x square of t. So nothing but what is the expectation of x square of t? So what is the expectation of any function? Nothing but what? If it is a continuous random process, so take what? Integration. So expectation of any function, nothing but what? That function into what? The density function. Therefore, x square of t into density function of theta. So what is here x of t? Nothing but a cos omega naught t plus theta. Therefore, here x square of t nothing but a square cos square omega naught t plus theta into what is the density function of the uniform random variable theta? Nothing but 2 by pi into d theta. And here a square is constant, 2 by pi is constant, bring it outside, then you can write on this as what? 2 a square by pi into integration 0 to pi by 2. You can write cos square theta as what? 1 plus cos 2 theta by 2. into d theta. Then differentiate with respect to theta, so integrate with respect to theta, and then substitute the upper and lower limits. Then you'll get the average power Px of x is equals to what? A square by 2 minus a square by pi into sine of 2 omega t. But this is a function of t. So if you want the time average power, then you have to take the time average of the expectation of t. So what is the time average function? So the time average of any function, nothing but what? Limit t tends to infinity 1 by 2t integration minus 2t. So that function into dt. Similarly, what is the average power of px of t? Nothing but this is a time average power. This is nothing but what? The statistical average power. And this is a time average power. Is equals to what? Limit t tends to infinity 1 by 2t integration minus t to t. What is px of t is equals to a square by 2 minus a square by pi into sine 2 omega naught t into dt. So if you simplify this, then what is the power you are going to get? A square by 2. So this is one method to find out the average power. What is the other method? Find out the autocorrelation function Rx of tau. What is Rx of tau? Expectation of x of t into x of t plus tau. After finding the autocorrelation function, substitute tau equals 0, then you get the what? The average power. So these are the two ways to find out the power. Next question, find the autocorrelation function if the power spectral density of x of t is given by Sx of omega equals to 1 by n plus omega square for omega greater than 0. So what they are given here? So they have given the power spectral density of the random process x of t. And what you have to calculate? You have to calculate is autocorrelation function. Then what is autocorrelation function? You can know the power spectral density by taking what? The inverse Fourier transform. Therefore, the inverse Fourier transform of 1 by 1 plus omega square. So previously I have seen the, so what is x of omega 2ab by b square plus omega square. What is nothing but the power spectral density of what? A into e power minus b into mod 2. Therefore, what is a power spectral density? The autocorrelation function nothing but what? A into e power minus b into mod 2. And what is Fourier transform here? Sx of omega is nothing but 2ab by a square plus omega, 2ab by b square plus omega square. Therefore, 2ab by b square plus omega square. Now, what do you want? You want inverse Fourier transform of what? 1 by 1 plus omega square. Therefore, what do you have to here? 2 into, what is a here? 1 into 1 by 1 square plus omega square. Nothing but what here? E power minus mod tau. But what do you want here? Only 1 by 1 plus omega square. So bring 2 here. Then what can happen here? 1 by 2 into e power minus tau. Therefore, what is a autocorrelation for the random process? Nothing but 1 by 2 into e power minus mod tau. So next question is the autocorrelation function of a periodic random process Rx of tau equals e power minus tau minus mod tau. Find the power density spectrum and average power of a signal. So what they have given here? They have given that x of t is a random process, and then they have given the autocorrelation function of the random process nothing but e power minus mod tau. So what you have to calculate? You have to calculate the power spectral density. So then what is x of omega is equals to Fourier transform of e power minus mod tau. Previously we have seen what is the Fourier transform of e power minus mod tau is nothing but what? 2 by 1 square plus omega square. Therefore here 2 by 1 plus omega square. Next, so what is average power? Nothing but Rx of tau at tau equals to 0. Therefore, what is Rx of tau? E power minus tau at tau equals 0. So e power 0 equals to 1. Therefore, its average for the random process equals to 1. Next question. They have given the cross power spectral density. Sxy of omega is equals to 1 plus j omega by k, where k is from minus k, omega is from minus k to k and 0 otherwise. So what you have to calculate? You have to calculate the cross correlation function. Nothing but you have to calculate Rxy of tau. In the same way, what is Rxy of tau is equals to by taking the inverse Fourier transform of Sxy of omega. So that equals to what? What is inverse Fourier transform formula? 1 by 2 pi integration minus into infinity Sxy of omega into e power j omega tau d omega. But what is Sxy of omega value? When it is from minus k to k, nothing but 1 plus j omega by k into e power j omega tau d omega. So if you simplify this, then you get the cross correlation function of the random process. Next question. A random process has a power spectral density Sx of omega is equals to omega square by 1 plus omega whole square. What you have to calculate? You have to calculate the average power of the random process. So first you calculate the autocorrelation function by taking the inverse Fourier transform of the power spectral density. After that, the P average is equals to Rx of tau at tau equals to 0. So here you can calculate the average power of the random process. So next question is estimate the power spectral density of a stationary random process for which the autocorrelation function is equals to 6 into e power minus alpha into mod tau into cos omega tau. So what you have to calculate? You have to calculate the power spectral density. So how do you calculate the power spectral density of the random process? Sx of omega equals to Fourier transform of Rx of tau. That equals to what? Fourier transform of 6 into e power minus alpha mod tau into cos omega tau. If you simplify this, then you can calculate the power spectral density of the random process. Next question. Find the autocorrelation function and the average power of the random process y of t if it has a power spectral density Syy of omega equals 9 by omega square plus 64. So what they are given here? They have given the power spectral density of the random process. So what you have to calculate? The autocorrelation function. How do you calculate? By taking the inverse Fourier transform of. So the autocorrelation function has been calculated by taking the inverse Fourier transform of the power spectral density. Therefore, find out the inverse Fourier transform of the power spectral density. Then what can happen here? 9 by 4 into e power minus 2 into mod tau. Then you have to calculate what? Average power. How do you calculate the average power? Px equals to the autocorrelation function at tau equals 0. Therefore, you get the average power. Next question. Find the power spectral density of an ergodic random process is to know how the autocorrelation function. So what they are given here? Rx of tau equals to 1 minus mod tau. For mod tau less than equals to 1 and 0 when mod tau is greater than 1. So what you have to calculate? You have to calculate Sx of omega. So how do you find it out? If you know the autocorrelation function, by taking the Fourier transform of the autocorrelation function, you can calculate the power spectral density of the random process. Therefore, in today's lecture, we have seen the problems on the power spectral density of a given random process x of t. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.